Hello, hello. Are we live? We here? We doing it? Are we 2026? Are we 2026? Harand, hello. Connor, hello. Yonismain, hello. Quacko, hello. Matt, hello. Hello, hello. ICS Boix, hello. Quacko, resubbing. 14 months he's been here. He's still not aboard yet. Still looks shit. Roberto, hello. UJ, hello. I think we're here. I think we're doing it. Okay, right. I much prefer ARM to x86. x86 is a hot mess. Jax, hello. Julian, hello. Okay, I want to. Am I missing a light? Oh, hang on. Lights are the same. I'm now a professional. I have a teleprompter, obviously, which meant I had to completely reposition where my camera was in the room. So it's now further away, but I need to zoom in, which I think is fine. Who knows about the colors? I don't actually know how any of this works. Okay, so let's begin at the beginning. I think in my box. Julian, thank you very much. Very kind. I will say, for YouTube members, there will be a new video this month. So if you're a member, you will get early access to that, which is exciting. First video of the year. What have we got? What are we doing? Where are we at? Okay, so we got this. It's kind of okay. It's not my best work. It's certainly not my worst. We can click and select things, and we can move them around, and we can kind of scale them and rotate them, and we can mess around with like some of the colors, and all having a pretty grand time of it. Beautiful. So what I want to do today is, I want to implement some basic lighting. So that the end goal, the intermediate goal, is a deferred renderer. But before then, so what we did last year, yes, pink is my favorite color. What we did last year was bindless textures. It's not as, I mean, it is bindless, but it's not quite the architecture we want. But it's fine. Those textures should be unbound. We're gonna be phonging. I'm not doing PBR. I just don't have the brain capacity for that, and also I don't think it's gonna make much of a difference for what I want to do. How am I compiling with Vim and linking the OpenGL libraries? What's the workflow? So I am using MinGW and the latest GCC to effectively cross-compile, and then because this is WSL, when I will produce, I will reify a native Windows binary and something WSL magic. When I launch it from the command line, it will launch it as a regular Windows process, at which point all the regular Windows code we wrote kicked in, and then we do our own OpenGL function resolution, do our own windowing, and up pops, up pops something like this. So that's pretty cool. So all the settings are in GCC. Yeah, all the compiler flags are in GCC. This is all open source, by the way. You can go and have a look at how it works if you want. There's a Docker. It's all built through Docker, so you can get Docker image. So you should be able to get reproducible build. It all should just work for you. What's up with my GPU ID? I don't know. This is just what whatever the WMI query gets me. This is what Windows tells me I've got. If someone wants to put on Twitch a little bang code in there, or bang git, whatever it is. Okay, so what I want to do is before we get to the deferred renderer, I want to get normal mapping work, I want to get specular mapping work, and I want to get like a light in there, but just like one single hard-coded point light, and then from there something we can extrapolate that out to the deferred renderer. Nope, this is all running. This is WSL on my main machine. This is it. Like I said, this is just. Where is the? I can probably show you actually. Where is the system info? Like I basically run GPU ID. I just do select all from Win32 video controller. Like whatever WMI gives you from that. That is just the string that I slap into my log. I'm not arguing with it. And then all these it has a bunch of stuff that just gets stuff, and then it just slaps it all into a struct, and then shifts it out, and then prints it. It could very well be because I have an integrated graphics card, so I wonder if that's probably. It's probably not. Do I just hang on? I'm saying a lot of words. I just join them with a space. I wonder if I join them with a comma, if that would be more obvious. There you go. So yeah, it's two graphics cards. Yeah, I know, right? The horror that is WMI. Hello. I don't know. I mean, I'm gonna at the moment. I'm writing shader code. Like I'm just like hard coding it as a string. Eventually, now that we've started building out some resource management code, like this will just become a file, and then I'll use a NeoVim, whatever it is, LSP or linter. Sorry, NeoVim syntax highlighter to write the shader in a file, and then just pull it in. But for now, it's fine. Okay, so there's quite a lot to do for this, because at the moment, we don't even track the normal. Okay, so vector 3, normal. This is fine, so this should be now. This is just my. This isn't really needed. This is more just to sort of sanity check that there's no padding. I probably could just use a pragma declaration or a line of or something, but for now it's kind of a cheap, a quick and dirty way of the compiler telling you that you've got the exact data that you want. Yeah, so I'm using vertex pulling, so there's no OpenGL vertex attributes, right? So you don't have to say, you never have to say there's like this bit of vertex data at this offset with the whole GL attribute pointer syntax. Like we don't have any of that, because if you look at our shader, right, we just have a struct for the vertex data, and then we just all vertex data for all models goes into one massive array, and then we can just pull those in, wherever it is. Here you go. Because then we just index that with the special GL vertex ID. Yes, I use Tmux. That's basically the one reason that's like the killer feature for me on Linux development environments is Tmux. Click. I mean, feel free to use the Docker file that I've got, because that will build GCC, analyze, cross-compile. I know you could probably edit it to not use MinGW if you wanted to. Shorts, yes. Press the button. Thank you. Okay, so let's patch this through and then see what we get to. So we should have float. No, unfortunately, we have to do floats rather than vex, because something stood for 30 padding is a nightmare. But then we just do right little function. I'm gonna hope that OpenGL optimizes most of this out. Who actually knows? But all this does is just convert that to a vec3, and then we're gonna have binding, I guess 2 now, out vec3 normal. Okay. And then normal equal. Oh, we've got Copilot on. Let's switch that off. Cheeky. Is going to be get normal. Just get normal. Vertex AD. And then down in fragment land. 3 normal, normal, and then I think we'll just do out color equals vec4 normal 1.0. Let's just render the normals first to see what we get to. Line 145. Where's the name collision? What? Someone's saying I'm gonna have an error. Oh, hang on. Do you mean that? Thank you. Okay, so then let's go to, I think we just, because we're just keeping it quite simple at the moment, I think we just have this, right? So what I'm going to do is I'm going to take from a previous project. The normals. And then something template magic, normals, shove that in there. That should work. AC, hello, glad you're here. Okay. Boo, boo, boo. Failed to link program. You can give me any more information than that? Sample program 22. Main 139. Which one was that? That was. Ooh, something in the. Okay, fine. Where? Can I not have normal as a variable name? What we should probably actually, I wonder if we should actually have that. Just like, sorry, lost myself for a second there. Maybe we should, just to prevent this from happening, we should effectively namespace these. Namespace them? I don't know. Sure. And then in, and then out color equals in in. I'm pretty sure it's live on YouTube. There's 90 people there. Okay, fine. Is it because... Oh, it's because the weird, like, where it just vomits it into the global space on the GSL shader. No, it's crashed. That's not liked it. I feel like I should have failed to link program. I do feel like it could give me a little bit more information than this. Specifically, so sample prog. Why is it failing to link? I see, resubbing. Thank you very much. Where have I gone wrong? Like this is... Yeah, to be honest, maybe that's something we need to fix anyway. So where do we actually throw that from program? Line 22. So we fail here, and the log is... fail to link program, which will be this message. So passing in link status, and then name, and then the log, I guess, is a null, is an empty string. Like, it should be here. What am I doing wrong? GL get program info log. Yeah, I think we'll see that anyway, but I'm happy to run that. Yeah, it's definitely empty. So returns the length of the string. I'm not accepting that. If I have not been passing the length argument, if the length of the returned string is not required of value, that's fine. Is it? Oh, is it too big? It may contain when the program object created. So am I? Because like I know. Like, obviously, this isn't the right way. You want to ask it how much space it needs, but... Param, hello. That has made no difference. So it's... Why? How strange. I don't know which problem I want to solve. Did I add that to the... Aha. I don't know if that makes a difference, but it should definitely be in there. There we go. Boom. That's why we need reflection. That would be a solved problem. Okay, so we are normalin. Our red RGB. Now I need... We could do lighting off that, but it won't handle transformation. So don't I still need the TBN matrix, which means I need a T to my N. Which unfortunately I don't seem to have. Like, I'm looking at my previous code, and this is where I'm cribbing from, right? This looks very similar. I've created cube, I've position normals, and then I've got the same... I just passed the normals in twice for the tangent, and I'm sure that's not right. Okay, fine. Well, let's just add basic lighting now. So how am I going to do this? I'm going to want a... How do I do it with the camera data? Because effectively what I want to do is... Yeah, but don't I need something orthogonal? Because don't I need to create an orthonormal basis? Isn't that what the TBN are? Aren't they all three at right angles to each other? So if the normal is the tangent, then when I cross product those, what do I get? Oh, what is modern C++? What a great question. Originally, modern C++ was just a term for C++11 onwards, because C++11 was such a fundamental change to the language. You got R-value references, you got a multi-threaded memory model, you got a whole host of stuff, and then sort of incremental changes from then kind of still the same. I've heard people refer to C++20 as postmodern, and I'm kind of hoping C++26 might be meta-modern or neo-modern. But yeah, I'd say like modern C++ pretty much means at least C++11, but that was like, 15 years ago. So there's probably no... The standards committee don't anoint it with a new, like, something modern name. It's just really what the community decides. Yeah. So an R value is just an X value or a PR value, right? But yes, an L value is something you can take the address of. L sometimes like locator, I've heard it used to refer to. But if you can take the address of something, it's an L value. An R value is something that will be used to initialize, used to create another value. So the return value from a function, like numeral literals, and then obviously you've got kind of like, and then you've got the different references. So L value references will only bind to L values, and R value references will only bind to R values. I thought I had a raw string literal. These are raw string literals. Unless you're saying like I should use like this. That would be... Whoa. Is that... Oh, it will only highlight it when I'm moving. Wow, that's... I need to look at Neovim for that, because I feel like it's kind of almost what I want. Anyway, right, what am I doing? How do I pass in camera data at the moment? So read-only buffer camera. So we have the view and the projection. So I think I'm going to want a new SSBO for light data. I could just stick it in a uniform. I literally just want... Okay, no, let's do it properly, because we're going to want these all eventually anyway. So let's go down... Okay, fine. Let's do F3. Oh, steady. Okay, read-only buffer lights. Let's keep it simple. So let's do vec3 point light pods. Let's just have a white light to start with, and we'll slowly build it up from there. So all we're going to do is slap in a point load. Point light to there, and then I think we can have a bit of fun with this, I think. Let's start building this up bit by bit, because it's so easy to get stuck in analysis paralysis and start trying to do too much. Where's my simple lighting code that I've written before. I need attenuation values as well. So don't I need that should be float point light 3, and let's just do the whole. Let's do point light color 3 and float point light attenuation. Oh, Zorsey, subscribe to Prime. Thank you very much. I can, but I'm going to throw most of this lighting code away anyway when we do a deferred renderer. So I'm kind of happy just to keep it simple for now. There's no syntax highlighting because it's just a string in my file. I've not moved this over to a separate file yet. Okay, so let's do... I need the frag position, and then I need the... let me write out the code, and then... Let's just do vec3 calc point and then so vec3 pos equals vec3 point light pos naught pos color and then let's see attenuation nope. Okay. Attenuation has a constant, a linear, and a quadratic part. So I'll just stuff those into the vec3 as x, y, z. $169. Oh, thank you. Yes, it is a lightsaber. Okay, fine. So we've got the details we need there, and then the float distance will be the lengths of the position minus the. So I'm going to need. Will that be global? Let's just do vec3 frag position, right? So that's going to be the position of the fragment in world space, I want to say. Which means we'll have to wire that in as well. We'll get there. And then the final attenuation will be 1.0 over. Oh, I'm just going to copy it because I literally it's just there you go. So you have a quadratic part, a linear part, and a constant part, and these all kind of come together to form the I guess the strength and the luminescence of the light. A vector is a three component vector, so x, y, z, or RGB, or whatever swizzle you want to put on the end. Intensity, yeah, sure, that sounds good. Okay, then we need to do vec3. The direction of the light will be the normalized difference between the point and the frag pos, and then the diff. You want the max, so that's the effectively the angle, I think, with in normal light. Actually, that's like 3n. Path these in n and light. So we get the angle between. So dot product is the angle between two vectors, and this will give us the maximum amount of that. So this is going to give us the angle between the normal or the interpolated normal and the light direction, capped, because obviously if the light is behind it, or I guess purely perpendicular to it, you might get a weird number. There you go. I'm not sure diff is the right word there. Well, what are you going to do? Vec 3, and then the reflection. So then you need to find the vector on the other side, the reflect angle across the normal. That's minus like the n. And then we need the specular intensity. So I'm just jumping straight, I'm going straight past Lambert, straight into a specular, straight into Phong. Possibly, I'm not a GLSL expert, so it might be the better choice. This is just what I've written before and I know works, and unfortunately that is kind of how a lot of some of the graphics stuff works, because I'm not an expert in it. Oh, it's the diffuse. This is the diffuse component. That's right. So I calculate the diffuse component, and then I calculate this. Let's just do the diffuse component to start with, before we start worrying about that. There's no syntax highlighting because this is just a string literal. There'll be some later. Right, that's it. That's the diffuse part. So let's just get that working first. So I should be able to return diff times at times color. I think that's right. And then out color just becomes vec for count point frag position. So that'd be like in frag position when I calculate it in normal. And then I guess R3, F3, R4 in frag position, I think. Which then means I need to swizzle this to X, Y, Z. And then for out frag position, frag position equals I can get this right now. So out frag position equals just the model, which will move it into world space, times the vec for get position GL vertex ID. All right, I think that's fine. In fact, actually, if we do this first, then we can save doing a second. Oh, it's not just model, is it? It's object data GL draw ID, because we have MDI. Times that, and then this just becomes out frag position. Save ourselves an extra multiplication. Thank you. Okay. I think that's kind of enough now, for now, like just to get going. Is that right? I think that's right. So if we now go to the scene, let's stick in here. Okay, so E, sorry, trying to think where I'm going to put this. I guess graphics is quite big now. I might create a subdirectory in there for lights, although I don't know if it's actually, don't know if it's worth it. Seems a lot of this could possibly be moved around. There's a lot of buffer stuff in here and OpenGL specific stuff. Let's just do what? Just e source graphics point light.h. Program once namespace UFPS struct point light, and then we're going to do hash include graphic, nope, utils, nope. God, it's been, I'm not maths, sorry, not looked at this since last year. Vector 3, and then hash include maths. Oh, I want to say, ooh, where's color? That's in graphics, obviously. Color. So sort of like janitorial work that's just like shuffling files around and stuff, I'll just do off stream and commit. Oh, I actually already have one commit on this branch before we started. I added the Matrix 3 class from the last project and added some tests. I forgot to mention that. That's already there, good to go. So let's do vertex 3 position, color, float, constant attenuation, linear and quadratic, vector 3. Congrats. How many tests did you have? Okay, so now we can go to scene. We can bring that in. Graphic. Point light, and then we can have but a simple point light. We go to main, where we create the scene. We're going to need, I forgot about this one texture nonsense. Dot light equals dot position equals that, dot color equals 1.0f. I think that is a constructor. And then I forget all the attenuation. Let me let's go to learnopengl.com. Lighting, basic lighting. I'm sure it's got some like decent. Oh, is it, where? Excuse me. here we go. Attenuation. Reduce the intensity of light over space. Blah, 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 blah. These values are good starting points for most lights. Oh, from Ogre 3D. I guess, I mean, constant 1. Let's try. I will wire all these up to ImGUI so we can change them. But let's dot constant equals 1.0f dot linear attenuation equals 0.7f, and then dot quadratic attenuation equals 1.8f. If we find values we like, I will probably never change them. Yes, it's. I think Julian's on it. That should be a little helper message for you there. Okay, so let's now go over to the renderer. We're gonna need another buffer. So we've got camera buffer. We're also going to want our light buffer. Renderer. Where do we create the camera buffer? Size of point light, and this will be the light buffer. Yeah, I've seen it. Light buffer. Okay, fine. So that will be triple buffered, coherent bits, consistently mapped, all the good stuff. And then we should be able to do at the beginning of the frame light. Let's do this in chunks. So that's binding the index buffer. Where do we bind the camera buffer? Or is it already bound? Anyway, oh, here we go. So 0, 1, 2, 3. Okay, fine. Oh, this code's getting a little bit gnarly now. We will need to tie this up. So let's, I feel like, yeah, this code's getting a little bit messy now. But let's try and keep these close together. So we're going to set up that, we're going to set up that, and then we're going to do light buffer dot right. I think can I do stood as bytes? I don't think I can just pass in a pointer to scene dot light. Don't think it will accept that. Because it's going to expect a spam. What I might be able to do is stood span point light 1. Yeah, that's what I'm trying to do. I'm just seeing if I can do it all in one. Can I do it all in one line? I kind of feel like that should work. And then I should be able to just do F3R4 light buffer dot native handle, and then before I forget, light. This should definitely be an RAI primitive. This should definitely be an auto. We definitely need an auto advancer. Why is that? not doing what I think it should. What's the actual compiler error? Extent. Okay, fine. So we can give it. We don't have to give it a dynamic extent. That's fine. ZU came in 23, I think. So it might not have been available in MSVC when I was using it last. I can't remember. Oh my goodness, what is this horror? Why can I? I feel like I'm getting there. No known conversion from point light to stood span. I'm pretty sure I can construct it with an iterator, right? And oh, do I? Oh, interesting. Okay, fine, interesting. This is only. It's explicit only if we don't have the dynamic cast, but you still need to provide a count. So am I just missing 1ZU? Oh, nailed it. I mean, it didn't work, but failed to compile shader vertex alpha. Vertex shader cast not allowed. Let's do 73J. Hang on. Yeah. Obviously. Undefined variable point, getting there. Yes, because it's pols. It's not wrong. It is sure not wrong. Getting there. Okay. Failed to link program again. That probably means I've not bound something in both of them. Have I not got this in the vertex shader? No, they're just incredibly different. Steady. I mean, what have I done wrong? Let's get rid of that in case that's causing us problems. Also. Oh. My light is wrong anyway, right? So I guess just... That, I think that's right for a light that should be in the origin, which would be between the two. Because there's no ambient light. So like that, if I move that up there, then I'll get a bit of the light underneath. Yeah, okay, fine. So that kind of seems to be working. You can see where the light is. Okay, so why... I've either got a padding issue or a maths issue. So if we look at point light, this should take up... Size of float times 369. Okay, so that's fine. And then renderer. If we go down here, this... I think it's just memory offsets, right? So it should just slap it over the top. I can't. There's no different to me copying like a random vector in it when a vector is vector 3 when that's just got 3 floats inside it. I believe so. I think GLSL does have a half float, but I'm pretty sure everything else, right, is all working off the fact that they are the same size floats. The fact that vertex data works, right? And this is exactly the same thing. So there could be a problem with the maths. Double check that. The frag position's right, because otherwise you wouldn't get any of the lighting. Okay. The normals are all correct, otherwise you wouldn't get any of that. It could be. We could... Well, I'll tell you, the next thing to do is just to get this wired up into ImGUI, and then we can start playing around with them, right? So let's do debug UI. So that begins that. So this, I want a collapsing header. If ImGUI collapsing header light. And then I need to... Oh, this is such a pain. Let's do the color. Let's do the position first. Ultimately, what we want to be able to do is render ideally only in the debug view, a little square that we can click on and pick and then drag around to sync with the light. So I wonder if we should do that first. So much to do. Let's do... Oh my goodness, what fresh hell is this? Oh, I've done it again. There's some weird... in my NeoVim setup, there's some weird key combination which ends me up at this. And I... don't know what I'm doing. Okay. Okay. Let's it seems to be potentially the attenuation is wrong. So let's wire those in first. Okay, so I want, what's the slider? Is it? Oh, float. Hang on. Let's do auto const attenuation. Attenuation equals scene dot light dot constant attenuation, and then we do if imgui slider float linear attenuation const attenuation. I think it's that. Two expect at least 4 have 2. Oh, is it a min and a max? Let's do 2.0f. I know 2.0f. Stick it in the middle. What's slider float 3? Does that just give you the ability to change 3 at once? Oh, interesting. Yeah, okay, fine. Let's do that. So we could do float at 10 equals scene dot light dot constant attenuation scene dot light dot linear scene dot light dot quadratic 3 attenuation a 10 because that'll decay to a pointer because C++. And then if that I think that will trigger if you click and drag that and it changes, at which point we can then do scene dot light dot constant equals atten 0. Right. Linear quadratic R2. Attenuation. Yeah, it's Italian. Renderer, and then we need to revert the change we did here. So that is to put back in diff times at. Okay. Let's see if this blends. I'm gonna pull back a bit just so I think we're there. Okay, fine. So let's do lights. So doesn't seem to be. So these don't seem to be making that much of a difference. Assuming they are being updated, right? I've got no reason to believe they're not because we write it into the thing every time. Ah, I was Latin. Close enough. What's wrong then? It's got to be with this nonsense, right? Does length return negative values? I do not know. It can't do. I think it's always the absolute length, right? Because even if you, presumably we could, I guess it's based on the distance. I just don't understand why. Right, okay, fine. Let's try and work out if it's a specific component, right? So this should be 1 divided by 1. So yeah, okay, fine. So as long as we don't make this 0, okay. So that works. So so is it something to do with the distance? Oh, it's there, isn't it? It's just very dark. Are these values just far too small? It doesn't help that we don't have an ambient light as well. What's some other recommended values? Right. It's got like arbitrary lengths on them. There's like, you know, if you're this many units close, but it's kind of meaningless at this point. Let's try making these a lot smaller. So let's do 0.22. And let's do 0.2. And let's just slide that back in. Oh, I don't know if you can see it. I can just see it. So it's definitely the values we've picked. Maybe it's just the boxes are massive compared to the strength of the light. Let's That's probably not too far off, given the fact that we don't have an ambient light. Yeah. We also aren't calculating any specular lights yet either, which I guess would also contribute more to it. But yeah. I'm gonna go for just like some of their. Let's just go for their like. It almost seems pointless doing this when you have to make them so small, but I guess. It's technically correct. Okay, fine. I feel like I've achieved the same thing as I had before now. So that's that. So let's do color will probably be an easy one to influence. Because we have color up here. What's the point? Sorry, I'm getting myself confused. Scene dot light. This will be light color. And if we do this back, we'll just remember copy this base straight back onto scene dot light. Okay. Quickly quit any of them. Okay, let's give that a go. Okay, nice. Getting there. So the next thing is position. So what I want to do is I want to render a small, very small cube. Ideally one that it itself is not subject to the lighting. Oh, I don't know how easy that's going to be, because I feel like we're going to have an extra. I think it's really important to be able to move the light, but it's actually a non-trivial amount of effort because I can't get the fragment shader to ignore this. I don't think I need a separate render pass. I think I need a separate material, one that basically has what we had before. So it's all the same gubbins, but just renders block color. I think I'm going to have to do it because it's going to be really important for debugging, I think. Do I move the shape? Do I take... I just feel like I'm making a lot of changes. I could just do it with sliders. It's not great, but it will... Let's just get it working with sliders to start with, and then we'll add that later, because we're going to have to shift all that shader code out to a file anyway. So I also feel like this should be a bit further down, because I'm actually going to be changing the attenuation very infrequently. So a 10 will be pols, and that will be scene dot light dot position dot x ry rz. Now stick that there, and then wherever else we have attenuation, so position, pols, and then essentially like, I don't know, minus 100.0 to 100.0. And then all this gubbins on the way back. So scene dot light dot position equals pos 0, pos 1, pos 2. Okay, that should get us what we want. Oh, what's slider scalar 3D? Like, we've got no idea where it's... I could probably have it so when you click this, it gives you the Imguismo over it. And then just make sure you've not got anything else selected at the same time. I don't have a transform. I could construct a transform for it. Just gonna quickly see what that looks like. Equals scene dot light dot position, and then hang on. That gives me the transform, and it writes into that, so I should be able to do const auto new transform, and then do scene. I could just pull out the individual elements, but I just can't be bothered. Light dot position equals new transform dot position, and this should actually be if we don't have anything else selected and we have the light open, then we'll that might make our lives a little easier. You need the camera data in there because that's how it knows where to render this, I believe. Okay, I think that works. Obviously, this is meaningless. That's pretty cool. I'm quite pleased with that. So I think we should commit this up first because quite a lot has changed here. Add to system info GPU info. Well, I only want it to work with one light because multiple lights we're going to just full on. I'm just going to go straight and do the deferred renderer. So this is just to kind of check that normal mapping works, specular mapping works, all that kind of stuff. Basically, it's going to check that. I'm going to use it to make sure the stuff that we're going to want to pass out on the multiple render targets, like the stuff that we're going to want to fill the G buffer with, that's what I'm trying to say is I'm going to use this now to check that the stuff we're going to shove into the G buffer largely looks correct, and then we'll do a deferred render pass. No, I've never done that. I've never looked at parallax displacement mapping. I don't know if it's worth it for this. I don't know. I think I don't really understand what the advantage is. That's just purely my ignorance. This is going to be a little bit grim. So add light to scene. That doesn't really get us anything. So just going to discard that. Add normal to vertex data, and then this is going to commit render light, debug light. Okay, let's now add some slightly more data. I think we're going to need an ambient light. Okay. And this is going to have, I'm going to have to go through and change everything now. Color, ambient, and then point, light. So this will become light data, lights. And then render is going to be incredibly unhappy with that. Here we go. So this now needs to become light. So this is going to have the size of light data. Ooh. Put light data in there, and then this is going to have float ambient color 3, and then this is going to be as const light data FTAS, and then I think I just add the ambient light to it. I can't remember. So I want to do vex3. So I want to do ambient color plus that. There you go. Obviously, that's it. If we were sampling a texture, we would have to multiply that by the texture, or the... Actually, so that should be... I guess the issue here is we're not taking into account the object colors anymore, right? Which is fine. We'll add that later because I'm going to have to go through and sample from all the textures anyway. Speak to AC. He's in charge of the community events. But yes, we'll definitely run another. Oh, and speaking of the community event, I'm editing the next video at the moment. Once that's done, I will look at doing it. I'm hoping to do a live stream on the results of the community event at the end of this month. That's kind of where I'm sort of shooting for at the moment. Okay, let's just keep things simple. So that's there, and then the debug UI is going to be really miserable. And then we should be able to do something like this. I'll just set amp color, lights, ambient, color picker, ambient, amp, and then game main. Give it a minute. This is going to be unhappy. So dot lights equals dot ambient equals color 1.0f 1.0f. That's going to be quite bright, isn't it, actually? So let's do 0.5f 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 dot r equals, try and be consistent, dot g equals, dot b equals, and then dot light will be that, and then I think I just need some more curly braces, bish bash bosh. Oh, have I not copied it out? I'll have a look at that. I thought I had done that. Boo. Invalid operations 2+. It's going to be the fragment shader, isn't it? So was that 81J? Oh, it's because it's a float array. That's why. Vec3 amp color equals vec3 ambient color naught 1 2 and then this would be color and then sorry, excuse me. Good spots. What a nightmare. Okay, yep. Yes. Right. Okay, right. It's quite bright. We can definitely tone it down a little bit. So here we should be able to just make that a little bit darker, and then we can see the point light doing its thing. Then we can make the ambient light red, or like green or something. Maybe not quite so aggressive. something like that. And then we can make the point light red, which will then blend. Okay, that's pretty good. Let's just quickly, I think that's just gonna be pretty much one big commit, which is not great. So add ambient light. Okay, I really want to try and get normal mapping done. There's an awful lot to do. I think we'll just see how much we can get done because we've still got to handle non-sRGB textures because of normapper's data rather than a sort of non-linear color space or whatever the governance is. So what we got to do, we need to load the normal. We need to treat it slightly differently in terms of how we process the data and how we upload it to OpenGL. We need to add another bindless slot, which again, I would just probably create another one of these to start with. Not great. Like ideally, there should be a massive array, but I don't want to change too much now. I want to kind of get the basic lighting working, and then when we refactor it, we know that we haven't broken anything. And that's it. Okay, right, let's so let's try the diamond one because that I think has got the best kind of normal map. So right, let's go back to main. I'm building it without any AI assisted tooling, so there's no Copilot or Codex or Claude or anything like that. I might ask an LLM a few questions just to kind of check my understanding, or maybe to produce some maths that would just be in an academic paper somewhere, but like it's all just purely being typed out. That's my plan anyway. Like here's a good example. He says, I've got a bunch of normals here for this cube, right? For these positions, at some point I will need a tangent and a bitangent vector. I will just copy and paste that into Gemini and say, give me the tangent and bitangent for this, and it probably will work it out. So yeah. Stuff like that, it's just mechanical and is, I think, an excellent use of an LLM. Like I'm not sitting there figuring out what all the orthonormal basis is for all these like TBN bullshit. I get the machine to do that. But the actual writing the code bit, I quite enjoy writing code and I find it quite fun. So, and as I'm here to have fun, like we'll be writing out the code. Okay, let's load a texture. So let me just hang on. I'm going to need some sort of usage, right? Let's start wiring this up. So let's go texture. So we've got in texture data, we've got a format. We're going to enum class texture usage. And in this, we're going to have, what am I going to call it? What did I call it last time? SR. Interesting. Did I not differentiate data? Oh, I did. Yeah, sorry. All right, sRGB and data. So sRGB is for anything that is like you want to actually render verbatim, like anything that contains color data. Anything that contains like mathematical data, like a normal map, which you don't want to interpolate with any sort of color space, like linear or whatnot, you'll mark it as data, and then you'll actually change slightly how those get uploaded to OpenGL. Change them to what? That's a great question. I'm glad I asked, because I cannot remember how I did it. I'm just looking up now. Do I need to care about sRGB if I'm not doing HDR yet? I'll probably just have the complete by tangents. I think it's easier. I'm not too worried about GPU space at the moment, so I'd rather put more data in there. Yeah, I don't think I need to worry about this because I'm not using HDR yet. I think if you just want to learn to program, I think Python's a great starting point, right? And I would probably recommend most people start with Python or JavaScript if you have no other expectation of what you want to learn. If you want to learn systems programming and sort of more low-level stuff, I think C is a great language to learn. Very small library, has pointers, manual memory management, a lot of like mechanics that you kind of need to understand, low-level access to the platform, so you can have quite a lot of fun with it. So that'd be my kind of suggestion, on the sort of Python versus C as a starting language. I'd say learn both. Okay, fine. Let's just leave it as is, right? Because I'm not worried about color spaces because I'm still in SDR land. I've already pressed the button. We will have to remember to go back and update all these when we add HDR, and we need to add HDR because I want bloom, but that's good things come to those who wait. So before in the previous project, I just stored the normal and the tangent, then I computed the bitangent using the cross product in the shader, but I feel that's kind of wasteful. I'd rather sacrifice space and just keep the shader as optimal as possible. Not that you need it super optimal for rendering 2 cubes, but here we are. Okay, right. Let's try... Sorry about that. Excuse the pun. Sorry about that tangent around sRGB. I was getting ahead of myself. Diamond floor. So this should be diamond floor normal. Okay. Oh, I've only got the one texture. Diamond floor albedo texture. Nailed it. All to be refactored soon. Yeah, I just want to get it working, Okay, so let's do renderer. So this should be albedo text F0R1. This will be normal text and then right. I gotta get this right. So I need to calculate all the light values and then multiply that by the sampled texture, by the texture sample, right? So vec for albedo equals texture albedo text in UV, right? And then the ambient color is that, and then we're going to do the vec for point color is that, and then out color equals albedo dot hang on, what nightmare, vec for albedo dot albedo dot RGB times color plus point. Yeah, I've seen it. 1.0. Is that right? Do I accumulate all the lights and then I use that as a multiplier on the underlying texture, right? I think that's right. I suppose we could check, because I'm still putting that texture through this. I just need to find out where do I bind the... Okay, this horror. Whatever this is. R1, the one normal. We could also render the normals to check that those work as well. Oh. Change something important. Implicit cast from vec 3 to vec 4 on line 86 of the fragment shader. 86J. Oh. There you go. To be honest, that actually should be .rgb, and then this with that. Okay. So now we should be able to change this to that, and then move the light around. And oh, we're not doing the specular as well. We do need to do that, I think, to make the normal map. Oh no, this should work. And then we should be able to make, I don't know, this like a green. Sort of see the influence of the point light there. If we make this, yeah, it really does knacker the okay, right, so that's good. So now we need to do the normal map. So there's a whole host of gubbins need to do this. What do I just need to sample it? Do I just vec 3 n equals texture normal text dot in UV dot RGB. I suppose we should probably swizzle correctly, XYZ. I have both chats combined. I just try and read what I can as I'm going along. Calc point, yeah, it calculates the diffuse. The calc point calculates currently just the diffuse component for the point light. It will do specular as well when I get around to it. n equals, and you got to shift it, right? Because you can't have a negative. Normals might be negative, right, in model space, but you can't have a negative color. So they're all, what was it, shifted. So that should fix that. And then n equals normalize n. So this will be eventually where we have TBN times, right? But we don't have that at the moment. Let's just see if this works. It won't look perfect for all of them, but it might look all right for some of them. Huckley, hello. Glad you're here. Okay, so now I should be able to just pass in n, right? Just throw away that vertex normal, I think. I think that is normaling. It definitely looks raised. I can definitely see the light moving across that. Of course, I think that's now wrong for... Will it be wrong for the top one? Because I'm not... No, that's right. It won't work if I rotate this. Let's get a bit closer. I don't think the normals move when I rotate this. Yeah, the light is the same. And it definitely won't work if I stretch it. In fact, I think all the lighting is messed up then, is it? Yeah, like... oh no, I think the light's just clipping inside it, isn't it? Yeah. No, I think that... Is that ballsed up? Yeah, that's not right, is it? Yeah, I shouldn't have this dark, rando dark quadrant. Especially when it's outside. Yeah, it is wrong. Okay, right, so now I need some tangents. Let me... I will... I'll ask the Oracle for some... We'll see what it gives us. Unless anyone can calculate them off the top of their noggin. We could actually spot check some of them. Given this vertex and normal data for a OpenGL cube, please give me the tangents, and by tangents. Not even spelled that right, obviously. Right, see what it turns out. Oh, I really wish it wouldn't put these comments in. Let's just get straight up copy this into main CPP straight from the Oracle. you should be able to spot check these because they should form orthonormal bases, right? Which, as in each triple pairwise triplet. Was that what I'm looking for? Okay. So 0, 0, 1, 1, 1. So that's definitely a orthonormal basis. 1, 1, 1. Sure, all look positively cromulent to me. I've checked 2 and I'm happy with them. Vertex data normal. Tangent by Jove, by tangent. I've started now. Size of times 3 plus size of float times 3. Yeah. I've just kept them all as separate components for now, but I think that's fine. Okay, so let's do render. We need to update these to have update normal UV. What order are those in? Normal tangent by tangent. Normal tangent by tangent. Don't forget to put them there. And then wherever I have normal CFL tangent, CFL by tangent. Okay. I mean, you'll need to use wiggle get proc address, right? If you want to use it from the Win32 API, you probably won't be able to resolve them just from get proc address. Okay, so now we need to construct our TBN. And for this, we're going to need the normal matrix. Now, last time I calculated the normal matrix on the GPU, but I don't want to do that this time. I want to calculate it. Oh, it's going to be quite a big change, this, isn't it? I might just calculate it now, and then just to see if it works, then refactor it later. Yeah, let's do that. So mat3 normal mat equals transpose of the inverse of the mat3 of the model of the object data. Object data should have this already pre-computed on the CPU, but it involves it's a slightly more in-depth change because we're going to have to change the interface of everything so that when you update the transformation matrix, it automatically updates the normal matrix, and I just don't want to do that now. It's a change we need to make, but I'm going to say that later. Yes, thank you. Well, I mean, I can kind of make some engineering concessions when I'm just kind of doing this for funsies, and I just want to make some progress. So normal needs to be normalized. I'm not sure. We probably not going to use this anymore, right? But let's. Do I even need the out.normal now? No, I don't. There's no point hoofing that over there, is there? Good spot. Okay. And then I need I need an out TBN, I think. So F3R4 out, mat3 out TBN, and then TBN equals mat3 of get normal GL, hang on, normal, hang on. Okay, let's do this. Vec3t is going to equal normalize the vec3 of why do I'm confusing myself now. Is it vec3 normal mat times vec4 get normal GL draw ID sorry, vertex ID 0.0. Is that right? VRN tangent by tangent, and then out TBN equals mat3 TBN. Yeah, but is that right? The goal of this is just to build out the tech that you would need for a simple FPS. It's not necessarily to build an FPS. Like, you should be able to run around and shoot things, but it should be all the tech that goes along with it. Okay, and then in this land, I should be able to do... Oh, hang on, my numbers are out of sync. 0, 1, 2, 3, and D. In mat3 in TBN, and then when I calculate this, I think it's just in TBN times the normal, right, that I've got from the normal map. Fuck it, let's see what happens. Blah. Oh, it's my... Why is it not like... Oh, it's because I'm not putting in here. Normals, tangents by tangents. Oof. Ambiguous. Oh, it's inverse, that's why. That 2 stated 2, where? Which 2 stated 2 where? here. Oh yes, well done. Fail to compile vertex shader. Ambiguous overload on line 101. What about... Oh, wait a minute. These are... I don't need this. Do I? Because these should just be... I'm not convinced about this. Okay. Let's get right up close to this. So if we... Is that... That's wrong. It's definitely going the wrong way. Does it help you... different color on it? No, does not help. I'm pretty sure that's wrong. If I shove that right up into that, yeah, what's... Okay, so what have I done wrong? Curiouser and Curiouser. Do I not need the... So this is what I'm cribbing from, right? This is what I did in the last project. I only constructed the TBN from the model matrix, not from the normal matrix. Do I not even need? Should this be... let's go back to what we had. Is it that? Oh, hang on. Oh, that looks better. I think. So hard to tell. I think that's right. I just feel like... No, because look, as I pull this down, why does the... I'm looking at this one here, right? If you can see it. Notice the shadow at the bottom is getting longer when the light is closer to it, and then up here it's swapped. So what happens if... So I think that might be right. Because when the light goes inside it, it'll do weird things anyway. Yeah, it is backwards, but I'm trying to... The question is why. I guess my bitangent and tangents could be wrong. My normal map could be wrong. Like, no, we think the normal map was right because we saw it working before we did this. We could modify it to show... We could debug it by showing the normals, right? By showing the normals. So I assume when you put them like this, do they go column major, presumably? So we'd want 0, 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Because what I'm thinking is we could just do out color equals vec4 in TBN 0, 1, 2, 3, 4, 5, 6 TBN 7 in TBN 8. Assuming that is going the way I think it's going. Zero, 1, 2, 3, 4, 5, 6, 7, 8. How's that? Array out of bounds. Yeah, I just... Why is... I don't understand my... That's a good point. Each index could be a vector. So it could be, I could want TBN 0, 1, 2, 0, 2, 1, 2, 2. That looks normally to me. I guess the question is what happens when you rotate it. That looks right to me. given those colors kind of interpolate between the two of them. So I do have, when I downloaded this texture, it gave me a DX and a GL normal map, and I used the GL one. So what about the tangent? I would expect the normal one to work because that was working before. What am I doing? I'm making this up as I go along. Can I just do like that? Yeah, there's why is there two reds? Pretty sure that's wrong. Why is rotating that and changing that one? They should be different colors, but they should behave the same, right? Those tangents are wrong. Right. It's not actually a great use of LLM for this because it's just predictive text, right? And it's not very good with numbers. Like it's just gonna guess based on human language what the next most likely coordinate is. Yeah, okay. Well, I've told it it's wrong, and it is now refusing to speak to me. There's got to be something online which has the... Ooh, you are correct. My previous answer assumed a standard OpenGL layout, but a closer look at your specific position array reveals that the vertex winding order and flow are unique for each face. Oh, so it's my fault. To get the correct tangents and bitangents, we must calculate direction vector from the bottom left. Let's give it. Let's give it another go. It's absolutely outrageous. Yeah. I know, right? Oh, after actually really looking at it, and nah, mate, you're having a laugh. There's no green. What I suspect I'm gonna have to do is I'm really annoyed I don't have this from the previous project. I don't know why I got it so wrong. I guess we just stopped rendering cubes quite early on. I'll probably have to export a cube from Blender and figure it out from that. Oh, what a pain. I was really hoping I wouldn't have to do all this. Like, there's someone online got somewhere. There must be somewhere that exists, like, I don't know, cube, normal, and tangents plus. I just want, values for a cube, normal, tangent, and bitangent. I wonder if Learn OpenGL has it. Like it must have it. Where's its advanced lighting? Normal mapping. Come on. I bet it doesn't do it with a cube. No, it does. It does it with a plane. God damn it. What pain and what an anticlimactic way to end the stream. I literally cannot find like. Oh well, this is promising. This is promising. Oh, this guy calculated it from scratch. What an absolute madman! I ain't doing that. Generate the cube positions. I don't know what you mean by generate the cube positions. I don't have the positions. I'm gonna ask it to try again. Still wrong. When rendering the tangent, I see multiple faces as red. Let me just check I'm not being stupid here. Tangent 0 and 2 by tangent 0 and 2, that's all cromulent. Definitely just rotate that into the model space. Oh, maybe one last try. Maybe I should help it out and say these are the indices. These are the indices. To be fair, I didn't actually tell it what order they were in. I was like, here's a bunch of normals. Can you create me? It should work, but yeah, I mean, like, well, I spot checked a few of them. They all seemed fine, right? Like, they all seem to form like a north normal basis. I'm not quite sure why. That's the missing link. Okay. What a weird. Wait, can you write that as two arrays? It's like pulled it all out into individual variables. That's just not want it to work. Right, last try, and then I'm gonna commit. and throw it into the sea and call it a night. Okay. Okay, this will work. I have absolute faith in the machine. Yeah, I mean, this doesn't look, it just doesn't look right. Unless this is right, and I've just misunderstood what I'm supposed to be looking at. But I would expect a tangent just to be different colors but behave the same way, right? What does it do with the what does it do with the bitangent? Because at least one of them works. I can always just cross product them. That's, yeah, it's just as bad. But we're pretty sure that 2, which is the actual normal values, works. Yeah, okay, fine. I mean, that is what I'd expect the colors to be different, but to still behave the same way. There's actually one super quick last thing I could look at. Let's look at. I'm really surprised I just don't have the tangents there for this. I think it's because I was using spheres to start with, and I think I had object loading. I'm just looking back at the old project. I think I had object loading working quite quickly. So I never... that's why I think I duplicated it. I think I just said I'd never need it. A little bit short-sighted of me. Okay, I'm going to call it there. Let me just comment this up. This is... broken TBN. And that would leave us at stream. Ooh, first double digits. Stream 10. I might not merge this branch today. I'm going to keep going next stream and get this finished. There's no point doing a release and everything. Before everyone disappears, there are, I think, at the start of the year, I think there are goodies. Hang on. Indeed. Yes, I do use CMake, for better or worse. Anyway, that is 1 month's free YouTube membership, which is actually a good month to have it because there's a new video. Video I'm working on at the moment. I've finished filming. I'm editing at the moment. It is probably the most complex video or project I've ever worked on. It's taken me about 3 months worth of working on it. So I'm hoping that that'll be out when it's out. A useless tautology for you, but it'll be out when it is out. But when it is out, you guys will get it a day or so early. Very close to 100,000 subscribers as well, which is absolutely crazy. It's nuts. That's just blows my mind. Okay, slightly anticlimactic end. Oh, should we see if there's anyone to raid on Twitch? Maybe we can spread some joy elsewhere. Same category. Is anyone C++ing today? There's a Russian chat, but it does say also in English, celebrating his streamiversary doing C++ engine dev. Let's drop in and say hello. Cue that up. Yeah, it's crazy. Yes, okay, thank you very much for everyone coming along. Apologies, it was a slightly anticlimactic end. I will just go and grind out that data for the next stream. It really won't take me long to do. It's just, I need to fire up Blender and put out things, and it's just bullshit, basically. But we're pretty much there. Once we've done that, I'm going to do the specular component of the point light, then we'll add a specular map, and then it will look pretty sweet. Shiny metal, and then, I don't know, basically big old array of textures, and then a deferred renderer, and we're basically done, and we'll ship it. Cool. Okay, thanks so much for coming along. I'm going to hang out on Discord for a little bit. Do come along and hang out. It'll be good fun. Otherwise, I'll catch you all anon.